So today we're going to go over a Kubota tractor. There's a couple things on the top of your sheets that you're going to have to fill out. If I can put this thing in there. Tractor manufacturer, this one is a Kubota tractor. We need the model number and then the FSU and the FS number. So the model number right there for this tractor is an L3430. Basically, those are just classifications that Kubota uses to determine, the engine size, horsepower. This one happens to be a 30 horsepower tractor. That's what that 30 represents on the back end of that. The 34 just has to do with kind of, different sizes, classifications, with their tractors. We're not going to get too much into this. This is not a tractors class, but we want to give you some of the basics on it. So just kind of labeling them correctly so that way you guys know this is an L3430. That's the model number. On the very top of this hood right there, you can see that we have the number 2272. This is a Fresno State number that we assign to all the equipment that we have here on campus. That's just so that way when we're servicing them, if we have issues, if we need to take those things in, we can identify, the hours and kind of keep track of everything that we have. So the model numbers are going to be obviously, printed on there, and then the little black stickers. Those are just the Fresno State identification numbers. So if you see this on any equipment, trucks and vehicles and all that stuff, they all have different classifications, and we're not going to get into what we have there, but that's kind of the basic thing. These are the tractors that we kind of use for training. They're an enclosed tractor. They're a little bit unique in kind of what they do. They're not like a standard kind of tractor, but there's a lot of parts that are going to be similar from one tractor to the next. So we're just going to kind of jump in. We're going to run through. I'm going to do this in alphabetical order. So if I skip a letter, just let me know. But I think I know my alphabet pretty well, so hopefully we won't have that issue. So as we come into the tractor, there's a lot of different controls, and you can see all these things with the blue tape. That's going to be our lettering system. The first one that we have here is A. This is going to be our clutch. I think we mentioned this a little bit last week, but it's kind of an important part that we need to make sure that we talk about. The clutch is going to disengage the engine from the transmission. So it's important that if you want to stop with these things, that you have to hit that clutch. There's also safety start systems on this one where you have to have the clutch pedal depressed all the way for the engine to start. If you don't have it depressed, it will not start the engine. So it's kind of an operator presence, making sure that somebody has to be there to where you can't just start this tractor without somebody in their seat depressing that foot clutch right there. So clutch disengages and engages the engine from the transmission. If you have any questions on any of these things, or if you need more clarification, let me know as I go through, but that one's pretty basic. If we go down to here, we've got this letter B, okay, and this one is going to be what we consider our differential lock. So what this differential lock, I'm going to kind of go around to the back side here. When you have these two tires that are in the back, okay, there is a differential that's going to be in between those things. And as this thing is operating, and your cars are going to be the same exact way, what happens is these tires are going to turn. The transmission is going to get power, and these tires are going to turn. When I start making a turn to the left or the right, it's going to slow one tire down, and it's going to speed up one tire. Because if you make a circle, if you were to turn in a circle, okay, the inner tire is going to have a smaller circle and needs to spin slower. The outer tire is going to have a larger circle that it's going to go around, and it needs to turn a little bit faster. So it aids in turning and makes it a little bit easier. Sometimes though, when you're in a field, and let's say you get to a muddy spot, you may not want those tires to spin faster or slower. And so we're going to use the differential lock to basically lock those tires together. So one tire is going to spin at the same exact rotation as the other tire, and that's just for the rear tires. If we go back up into the front, you can see that differential lock right there, you basically are just going to take your heel of your foot, you're going to depress that pedal down. It's going to engage that differential lock. As soon as you let your heel off of that, the differential lock disengages, okay? And I believe that is a question that we are answering today. One of the 5 questions, okay, is how do we disengage it? It's not something that we keep engaged as we are going through these systems, okay? Questions with the differential lock?
Could you say it once more time? How do you disengage it? Sorry.
So you disengage it by simply letting your foot off of that. So your heel of your foot will depress this down as you're sitting in the seat. Okay. And then once you let your foot off, it's going to always spring back up. So it's never locked into position. Some vehicles may have a differential lock that you can actually engage and keep it locked in. Most tractors, they're not going to be that way. You have to physically put your foot down on that and keep it on it, or else it's going to disengage itself. So it does it automatically.
Okay, thank you.
How you turn it on is by the heel of your foot, and then turning it off as you let the foot off of it, right?
Exactly right. Yep. You just depress it down and then you lift it up. And it's really only used when you're in a field and you need it. Let's say like it's a wet spot in a field where you potentially might get stuck. That's where you're going to use the differential lock. But most of the time we leave them unlocked unless we absolutely need to. Cool. All right. Moving on to C. Again, if I move fast, just let me know. Right next to that one, we've got this little, I don't know if you could see this little label right here, where it looks like the fronts, their rears are going to be locked kind of together. This is what we're going to consider our mechanical front wheel drive. I'll kind of zoom out on these things for you so we can explain it a little bit better. Mechanical front wheel drive is similar to a four-wheel drive, but it's not exactly the same. And especially when we talk about tractors, we're dealing with things that are a little bit different. If you notice on this tractor, can you see the rear tires are bigger than the small tires? Okay. If you have this on a tractor, and this one, it does have the gearing inside the front. Some tractors don't have that. The tires are going to be smooth. They're not going to have these ribs kind of built into these things. If you have the four-wheel drive, if you will, okay, you're going to have aggressive tires on the front and on the rear. But to differentiate between four-wheel drive and mechanical front-wheel drive, okay, on a tractor, mechanical front-wheel drive can be engaged and disengaged. So the front tires, if it's disengaged, are not going to spin at all. If we're on the road, we don't want mechanical front-wheel drive running. The reason that we don't want that is these front tires are going to spin faster than the rear tires. And what that's going to do is it's going to tear up the tires. It can tear up the equipment. You only use it kind of like the differential lock when you need to. So if you're running through a field, if you have like a disc on the back end that you need that extra pulling power with, you're going to engage that differential, or sorry, the mechanical front wheel drive. Now this lever, as opposed to the differential lock, when you push this thing down, it's going to stay engaged until you release that lever and pull it back up. So it doesn't have a spring system like the differential lock. So this mechanical front wheel drive is going to be engaged until you disengage it. Four-wheel drive on a tractor is a little bit different. Typically, what you're going to see on a four-wheel drive tractor is it's not going to be able to be engaged or disengaged. Larger tractors typically are going to have these things. You'll identify a four-wheel drive because the rear tires and the front tires are going to be the same height. Okay, they're going to be spinning all the time. Obviously, because you can't disengage it, you can run them in position on the road. But because they're the same size, one tire is not going to spin faster than the other one. So when we think about mechanical front wheel drive, often referred to as MFWD, just because it's an abbreviation that's easier, it's kind of more similar to a vehicle or a truck where you can engage your four-wheel drive and you can disengage it. But in a tractor world, we talk about mechanical front wheel drive versus four-wheel drive. Most small tractors are going to be mechanical front wheel drive. What questions do you have on that? Good. All right. I think that was a question too that we had. Let me grab that paper here. Yeah, we did. What is mechanical front wheel drive? So hopefully that kind of explains that. Another one that's going to be on our question is D right here. This is what we consider our range selector. And this one's going to be a little bit different because the transmission inside of this tractor is a hydrostatic transmission, meaning we don't necessarily have gears that we're selecting. These things are all driven by hydraulics. And so on this range selector, we have a high, a neutral, a medium, a neutral, and then a low. And these are going to select different speeds for us. So if we're wanting to do an operation that's going to require us to go slow, we're going to want to run in the low gear. If we're driving down the road, maybe we're not actually pulling anything, in the ground, we're going to want to use the high because it's going to get us to our place faster. Now, all tractors are going to have a range selection, and then they probably are going to have a gear selection as well. So on the range selection, most of the time it's going to be off on your left-hand side, kind of where the driver's seat's at. And they may have a high or a low. They may also have like a turtle mode where they can go really slow. It depends on the manufacturer, depends on the tractor. But the high, mediums, or lows are designed for us to run, different speeds through a field. If we're spraying, we may run a little bit slower. The difference, and we're going to get to the PTO here in a little bit, the PTO needs to run at a certain RPM. And so if I run in a high gear and I run at a high RPM, my speeds are going to be faster. So your range selectors are kind of your way of keeping your engine RPM up, so that way you can run equipment in the back while also keeping the gearing low, so that way the tractor drives slow enough. Otherwise, we're going to drive too fast. So the range selector, okay, is D. What questions do we have? I will talk a little bit more about how we select different gears and how we go faster or slower in the next couple of ones. So let's go kind of to the back. We did D, now we've got E. This is the one that I showed you last week that we actually didn't have on the tractor, that New Holland that we had. There was no slow moving vehicle sign or SMV sign. This should be on the back of a tractor. It should also be on the back of all equipment. If we're running down the road, this is what we should have. Theoretically, if they're not running down the road, we don't need that, but quite often we're gonna do that with a tractor, even if it's just to drive a quarter of a mile, we might drive them on the road. Good practice, just leave them on, so that way they're there. That way, if you do touch the road, you have these slow moving vehicle signs. They should be in good working order too. I think we talked about that on the the pre-operation checks. Make sure that they're not faded. These things do have a reflective material with them. So that way we can kind of see the difference, in that color. So if you get lights that kind of hit it, kind of like a bicycle, it's going to reflect back at you. Pretty simple. Okay, I don't think we'll have questions on that. But if you do, again, just stop me. Now, when we go down to the bottom here, we're going to see F, okay? And this F, if you remember from last week where we had that aero fan that was kind of connected, that spray rig that was connected to it, the PTO shaft was actually connected, and it's going to connect into this one right here. Now, this one you can't see because we actually have a cover. These tractors are for training purposes only. We don't use them in the field. We literally just use them to drive and to teach parts ID and stuff. So this one, the PTO shaft is covered. But PTO shafts, there's really kind of there's two designs, but I'm kind of lying because there's three. There's a 540, which is going to have 6 splines on it. So there's going to be splines that's kind of covered up in here. And you will see those splines on the inside. Most small tractors, 80 horsepower, under 100 horsepower, they're going to be a 540 RPM. So that means at a certain RPMs on the engine, these things are going to rotate 540 times per minute. That's important because certain equipment is going to be connected that's going to be designed to run off that 540 RPM. On larger tractors, we're going to have a 21 spline connection, and that 21 spline is going to be 1,000 RPMs. I say that there's 3 of them because John Deere likes to, make their stuff a little bit different. So they've created a 20 spline PTO that runs at 1,000 RPM. And you can imagine you can't connect a 21 into a 20 because those numbers don't line up right. So they want you to use their tractors with their equipment, so that way you're forced to buy their equipment and not somebody else's. But for the most part, they're standard. You're going to see a 21 spline. There's going to be a whole bunch of different, like gears essentially that are on the inside of that or on the outside of that. It's going to be able to connect PTO equipment. Again, most smaller tractors, 540 RPMs are what you're going to see. Questions with PTO stuff?
Basically, sorry.
No, go ahead. Good.
The only difference between the two is that certain equipment can only run on 540 and certain equipment can only run on 1,000.
Yeah. So when we talk about like 1,000 RPMs, it's running 1,000 rotations per minute. So if you go from a 540 to a 1,000, you can have a piece of equipment that's designed to run at 540 revolutions. If you almost double that, it's going to tear the equipment up, if that makes sense.
Yeah.
There's no adapters and things like that that we should be using because it's going to destroy things. Or
Right.
if it's likewise, if it's 1,000 RPM and it's, you know, if it should be that and it's running at 540, it's probably not going to run properly. And we'll see that as we start seeing different equipment, we'll be able to kind of run through and see those things. So that was what, F? What do we got next? E? No, that was E, F, G. I got to know my alphabet here. So in the back, we're kind of on the right-hand side of the passenger here. You can see those big words, PTO. We've got this little linchpin right here, which shouldn't be on the side of that tractor like that. But on this one, you're going to notice, and this handle, okay, what color is that? Hopefully these colors come out good.
Yellow?
Yeah, it's yellow, okay? All PTO levers, this one's a mechanical lever. Sometimes some tractors, they're electronic. They're going to have a yellow handle on them. That's going to be a standard thing in the industry. If you get on any tractor, and obviously not like an old tractor, but anything newer, you know, you're going to see a yellow handle on these things. And that yellow handle is going to indicate that that is your PTO. Now, when we're running these PTOs, when we turn them on, we want your tractor to be on, and we want your, I don't even know if I can see this or not. So on the front of the tractor, we've got this little gauge right here. This is the RPMs that the engine's running. And typically you want to run about 2,200 RPMs to get your PTO to spin up to speed. If I was running it only at 1,000 engine RPMs, that PTO in the back is not actually going to engage. So you actually want to increase your RPMs, and that's kind of where your range selection kind of comes in to help make sure that you're running your engine so that way your PTO gets the right speed, but you're not running this tractor real fast through the field, especially if it requires us to drive a little bit slower. But when you engage your PTO, you want to do it when your RPMs are low. Okay, you don't want to jam this thing into gear while it's running really fast because the gears need to mesh up together. And you will hear grinding if you do that. So when you start your engine up and you're ready to start your PTO, you want to engage this lever slowly with low RPMs. And then once it's like fully engaged, and locked into place. I don't know if I can do that now. So I can kind of lock that into place. Once it's locked right there into place, okay, then you can increase your engine RPMs, and that's going to give you, you know, whatever PTO speed that you need. So it's got to be done at a low RPM for it to engage, and then we can increase that back up to it. I believe some stuff on the PTO is one of the questions that we have as well. Questions with that stuff? All right, G, we've got H, and I think we talked a little bit about these last time as well. H is going to be our left and right brakes. They are locked together with this little lever right now. I can kind of get this thing back up around. Let's see if I can get you guys to see that. You can see this little lever just kind of locks them, right? And if I push them down, they're both going to come down together. If I'm in a field, let's say I'm running through an operation and I have something attached to my 3-point hitch, I can push one brake or the other brake to get these things to turn. This is where your differential lock is going to kind of come into play, because if I apply pressure to one brake, what that's going to do is it's going to slow down one tire, and it's going to cause, like this tire, if I hit my left brake, it's going to cause this tire to stop turning, and it's going to put all the power into your right-hand tire. That tire is going to spin faster. That one's not going to do it at all. And your differential lock is allowing that to happen. And then you're going to be able to quickly turn around and do almost a 0 turn radius turn while you're in there. You don't want to do this while you have a piece of equipment that is a trailering piece of equipment. This one doesn't have a drawbar. Typically the drawbar would come out underneath here. So if we have like a trailer that's hooked up to that, that's got its own wheels, we wouldn't want to do that. We would do that though if we have a piece of equipment connected to our 3-point hitch. So you got your top link, your left, and your right link. These things use hydraulics to lift up a piece of equipment. And I will, like I said, I'll make a video on how we properly hook up these things and unhook them. We have just little concrete barrels that we hook up to for practice. So I'll do that and we hook those things up, but those things get completely lifted into the air. There's not anything else that's attached to the ground. Once we lift them up on the 3-point, everything's up out of the ground and you would use those brakes to make those turns. Most of the time we don't need to, we don't mess with it. It's not something that we really need to do, especially in what we're doing here. Questions with your brakes? All right, now this one's gonna be a little bit different from most tractors. Okay, because this is a hydrostatic transmission, we have this little foot pedal that goes forward here and back that way. So for us to be able to go forward, we simply are just going to turn our engine on. Okay, we'll get our RPMs up and I'll show you on the next one how we adjust our RPMs, and we push this foot pedal down. The more we push it down, the more power it's going to give us. So we can go kind of halfway on this pedal and it's going to go forward at half that speed, or you can push it all the way and it's going to give you all the speed depending on your range selection that you selected over here and how much RPM you have on your tractor. To go in reverse, you simply push this pedal and you go backwards. Okay, so there's no gearing that you're actually going to select to be able to go faster or slower. Some tractors will have a forward reverse lever. So they might have like a neutral position, a forward and reverse, and then they might have gears 1, 2, 3, 4. They're actually using that tractor that we use up here. They're using it in the Almonds. So when I get a chance, I'll show you guys, the gearings on those things.
I have one. Do you want to see it?
You have one?
Yeah, I'm in one right now.
What are you doing?
Mowing.
Okay. You know what?
I'm done though. I'm not moving.
let me finish this because my computer, my phone and my computer, if I kind of jump back and forth, they will kind of create a lot of distortion. So when I get done with this, I'll have you show everybody that. I'll pin your video and then we can go from there. Cool?
Okay. Yeah.
All right. So yeah, so this hydrostatic transmission is a little bit different, right? Just forward, reverse. You have your high, medium, and low range right there. Now, the last thing that we do on a tractor is we've got our little hand throttle right here. Most tractors are going to have these. Sometimes they have a foot pedal and they also have a hand throttle. The hand throttle is one of those that we use quite a bit because you can take this and you can pull this back a little bit. And what that's going to do is that's going to hold your RPMs at a steady rate. So if you're doing an operation that requires you to maintain a certain speed, you can get your ranges and all that kind of stuff selected. And then you can pull this hand throttle down and just let your foot off the clutch. And this thing's basically going to go whatever speed it's going to go. On this one, it's a little bit different because you have to completely depress the foot pedal down. If you go halfway or part way, it's going to give you more or less speed. We typically in this class do a speed lab where we actually drive these things and we record the speeds, and we do that. Because you're not here, we're not going to be able to do that, but I will show you the math that we do to actually run through that, and I'll give you those scenarios and maybe try to make a video kind of demonstrating how we would do that. But I really enjoyed that lab. That lab's really fun. Some of you have probably done that lab in another class with me. But it's a really fun lab to be able to do. But the hand throttle really comes in handy when we're like spraying, when we're disking. You set these things up and then you basically just run. You've got the speeds already set up. You just let your foot off the clutch and you're good to go. So hand throttle is going to maintain a certain speed, and that is J. It's a little bit cut off, but that is letter J. Questions with that? All right. What do we got? K is next. If we go down here on this engine compartment, okay, I think last week I showed you that New Holland. We had that dipstick where it was also a fill station. On this one, we've got our dipstick, okay. You can see we've got some oil. It's kind of shiny. It's not real dark. I don't know if they changed this thing recently. We haven't ran these tractors for, I don't know, a couple of months because we haven't had students. But anyway, so most of the time they're going to be on this right-hand side. But our oil filter right here, when we do service changes, when it is time for the oil to be changed, you want to change out the oil filters. This is pretty much the same thing that you're going to have in your car. Here on campus, we have the maintenance shop that actually is going to handle those things. We don't do the maintenance out here, but when it needs to be done, we take it up to the shop where we call them and say, hey, this thing needs to be maintenance. That's part of the numbering system where they come in and they're able to kind of reference these things. They know when it was serviced. They keep all the records and all that kind of stuff on those things. So. Oil filters need to be changed when you change the oil. This is not something you're checking on your pre-op checks, but you might get some leakage from here. There's a little O-ring where it kind of attaches. And as these things start to wear out, that O-ring will wear out and you'll see a lot of drops typically coming from there. But very common that they'll leak from the oil filter. And if you change that, you'll get a new one. L, this is going to be the water separator for the diesel. Diesel can sometimes have water. That would be bad for an engine. So the diesel, what it does is it's going to float through this water separator. Water is heavier than diesel, so it sinks down to the bottom. The diesel floats over the top, and then it flows up into the rest of the engine. So it basically allows that water to kind of drop down, so that way it doesn't get into your engine. These things will periodically fill up with water, and when they do, we need to make sure that we empty them out and then kind of clean them so that way the water doesn't fill up all the way and get into our system. So here you can kind of see there's a little bit of a separation right there. Okay, and this one's okay. We don't operate these things all the time, but there is a filter that's on the inside of this thing as well to kind of help filter that diesel fuel and keep contaminants and different things like that from getting into the engine, just like our air cleaner does, except for the diesel fuel. Questions with those two? All right, we're gonna do the last one. Uh-oh, where are we at? Okay. This one right here is our alternator. So as we are running this tractor, the alternator should be charging our battery back up, but then it's also taking all like the running lights, the front lights that we have. We've got lights that are up in the top. We've got the hazard lights in the back, the ones on the side right here. All the little electronical equipment. There's this cab tractor has an air conditioning system in it. So to run the air conditioning, this alternator is essentially what's going to allow us to have power. Pretty much the same thing that you're going to see in your cars. Especially on this one, this is almost probably, it's probably the same exact model that they use in some cars. Larger tractors require larger starters and alternators that are really, really expensive. These ones are probably about $100 when you need to replace them. Much like your vehicles and stuff, they're not too terribly expensive, but it's kind of our powerhouse. It's what generates the electricity and make sure that our batteries are charged so it can start the next time, and that any running equipment that we have is going to stay running for us, especially if we're doing an operation at night where it's dark. We really want to have those lights to ensure that we have that safety there. Cool. What questions do you guys have on this tractor, or any of the parts or anything like that we've kind of talked about?
So the hydrostatic transmission, I believe, was I, and that just produces like speed, or I kind of missed that one, I think.
So that's the I right there. That's
Okay.
the reverse pedal.
Okay.
So, I mean, it's kind of it all is part of the hydrostatic transmission, your range selection, and that foot pedal in conjunction with your throttle right there is going to determine your speed, if that makes sense. So it's a combination of those things. So I think this one, I just have it labeled as a forward or reverse pedal.
Okay.
The tractor as a whole has a hydrostatic transmission, and it just uses hydraulics, not gears. Like, some cars, or if you think about like a manual transmission, you have physical gears that are intertwined with each other, and that's what creates the speed and the force. This one uses fluid dynamics to basically get these things to flow. So there's no gears on the inside of these things at all. It's just hydraulic fluid, which is good because there's less parts to essentially fail. If you don't have metal parts rubbing against other metal parts, there's less wear and stuff like that. And you have, you can get any kind of speed. You can fine tune the speeds on these things more than you can on a geared tractor. So there's a lot of advantages. It's more expensive though. So it's kind of like, what do? Do you pay more money to have that variability, or do you not care and pay a little less for just a standard transmission tractor? What other questions do we have? Okay. I'm not sure who it was that has a tractor, but I'm going to go ahead and I'm going to leave this. I'm going to go back into my classroom, and then we can maybe show you the geared tractors, which is a little bit different than these ones. And then basically let you guys go after that, and we can let you answer those questions on your lab sheet.